Good morning, everybody. Today we are starting our new topic, templates. If you have any questions,
You are muted.
I am muted. Thank you. Let me see if I have enough number of people. I am recording. I am not muted. Let me see if that scary guy is here. I am going to kick him out. I don't see. So he changed his profile. Okay, good. So today we are going to talk about templates. As always, we will try to talk about code reuse. We will try to talk about abstraction. And templates are a very good way of achieving both of them, abstraction, code reuse. They are basically not part of the object-oriented programming philosophy, but they are very helpful in terms of code reuse. Write your very generic code and use it many times later. That's one thing. The other thing is that you concentrate on your algorithm part, not be concerned about the types that you are going to use. For example, sorting algorithms, when we teach you about the sorting algorithms, we don't start from the back. Start from the When we talk about algorithms, we don't talk about this is how you sort integers, this is how you sort doubles, etc. We give you a generic algorithm that will sort all kinds of sortable things. Okay? So templates are kind of like that. I mean, they don't care about the types that you are using. You specify the algorithm. Later you say that I am going to use this algorithm with the integers or doubles or day of year objects. That's how they work. So they are very nice in terms of algorithm abstraction. They are very nice in terms of code reuse. So that's what we are going to do now. We are going to do this templates thing, and I'm going to tell you how. Okay. As always, the idea is nice. We say things theoretically that sounds very nice to our ears. But in reality, there are some complications about technology, about compilers, about the history of the language. So we won't be able to achieve what we say at the beginning, but still, templates are very good ways of achieving code reuse and algorithm abstraction. In fact, we have been using templates. Vector, the class of vector, is an example of a template. When we say I have a vector, okay, immediately I know what I can do with the vector, but vector of what? Doesn't matter what vector of what. It's a vector of integer or double or vector of day of year or vector of vector, doesn't matter. So we have been using the vectors, so now we are going to learn how to make our own vector kind of classes. For example, we are going to remember PF array D, we are going to convert it to a template structure, so it is not going to be PF array D anymore. It's going to be PF array because it's not going to work with doubles only. It's going to work with anything. Okay, so let's start then. So let me show you this. We know this kind of a function, swap values. It takes two integer references, and I will swap their values. Okay, I will swap their values. That's what I do. Okay, so there's a temporary integer, and you know what we are doing, right? So this is very this is very simple code. It's very useful, especially with the bubble sort. We use swap values a lot, but it only works for integers. If I if I wanted to make it work for the doubles or the characters or the day of year objects or the vector objects, whatever, okay, I need to overload the swap values function. So instead of integer references, I have double references, character references, day of year references, etc. And that's kind of copying and pasting code, right? It doesn't sound very It doesn't sound very nice in terms of software engineering point of view. So okay, so the code is nearly identical between these two. It's nearly identical. All I did was I just copy pasted this, and I did a search and replace on the integer keyword, and I replaced all the integers with characters, and that was it. So we don't like it. We don't like copy and paste code, because if there is a mistake here, I just made it worse. And the code is very similar. If I want to change something in this function, I have to make that change in all the other copies. So I don't like it. So we have to come up with a new way of doing this. So that's what the templates are. Okay. So you say that I am going to write a function named swap values, but this is not a regular function. This is a templated function. Okay. In this templated function, I will represent some of the types with this generic type T. So this swap values function, templated function, takes two T references, makes a new temporary T, and assigns variable 1 to this temporary and does the regular swapping operation, and then just we are finished. That's it. So this is a templated function. Okay, this is a templated function. It doesn't know anything about the types. All it says that I assume that there is a generic type T. That's the template header. Okay, you are saying that I am not writing a regular function. I am writing a templated function here. That's what I am doing. Okay, so once you write this, okay, it is available for you to call now. You just call this function and that's it. You just call this function, and as soon as you call it, during your let me get rid of this. As soon as you call it in your main function or anywhere, okay. Let me open my one. Okay, so this is my templated function swap values. It takes just two templated type names, okay, and as soon as I call this one, okay, in a function, if I can find my function, where is my function? Why don't I open the book itself? And yeah, I think it was already open. It was open. Okay, here it is. Okay. So this is my swap values function that I didn't like because I had to copy it, and this is my template now. Templated function, okay, for the doubles, and well, let me show you. Okay, this is my templated function. Let me get rid of this. That will be clear later. Okay. Templated function before the main. Okay, this is the start of program. Before the main, I have this templated function here. Okay, and inside main, I make two integers. Their original value is printed on the screen. Okay, and it will print 1 and 2. I call the swap values. As soon as compiler sees this line, line 20, it produces a swap values function that takes two integer references, because compiler says that are there any swap values functions available that I can call? No, there is now. Okay, is there any templated function that I can instantiate? Okay, yes, there is a templated function. What is the type of integer one? It is int. If you replace this t with an int, this function can be callable. Okay, this function can be called. It's a callable function now. So as soon as compiler sees this line 20, it produces a new function that takes two integer references, and it compiles it, and it produces code to call that function. Okay? And it produces code, and it continues compiling it. Okay? When I run this, so that function is called, and those integers will be printed out. Then I have two characters. When I come to this line, the compiler says that, are there any functions named swap value that takes two characters? The answer is no, because there is one function that takes two integer references, but there are no function that takes two character references. So again, the compiler does the same thing. It produces another function that takes character references, two character references, and makes a call, and it continues. So what I'm saying here is that as soon as you make these calls, okay, by the way, these all are happening during the compile time, okay. Whenever the compile sees this function call, it looks up the function list. Are there any functions like this? No. Is there any template that I can instantiate with these types, new types, characters or integers? Yeah. So I am going to instantiate it. So after line 26, compiling line 26, you will have, at the end of this line 30 maybe, you will have three functions compiled. One of them is main. The other one is a swap values function that takes two integer references. Another one is swap values function that takes two character references. Okay. So this template instantiation happens only during the compilation time. During the runtime, your program doesn't know whether those swap values functions come from originally from you, like copy pasted and replaced, or instantiated from the templates. So templates are only compile time thing. During the runtime, your code wouldn't know there was a template or not. Okay, so you wouldn't say this is an expensive line to execute because the compiler has to produce a new function and etc. No, that's not true. Okay, this is not an expensive line to execute. It might be a little bit expensive line to compile, but we usually don't care about the compilation time because compilation happens only once or twice. But your runtime is important because millions of people will be using your executables. Okay, so that's the idea. Very, very simple idea, but very useful idea. So using this idea, we can write our generic algorithms, like this is the swap algorithm. I just implemented the swap algorithm without telling what kind of values, what kind of types it's going to work on. And later, when I do the call, compiler automatically generates one function for me. Okay? Any questions so far? Yes?
Why it's class, its types class, type of T?
Well, I mean, you know, usually they say that don't use class here, use type name. Okay? Type name is a better keyword, but at the beginning, for some reason, somebody said that it is class, and the name stuck, and we keep using class. But I mean, they always say, all the textbooks, everybody, they say that use type name instead of class here because class is confusing. But okay, well, I mean, the answer to your question, I don't know, but we do. Yeah.
Is the range of this T just for one function or more?
Is there any?
Is the range of this T just for one function or more?
No. Well, you say that, okay, you are saying that when I write this template class T, okay, this template header is only valid for this function, okay? So you may say another one, template class T, now sort, okay? It could be happening. So you don't have to use T, of course. You can use any identifier names. It's like a parameter, okay? It's like a parameter to a function. So this is only valid in this function definition, and you can choose any name you like, but usually we choose one capital letter, okay? One character capital letter, like T, L, R, etc. Okay. By the way, you may have more than one you may do this. You may comma class R, and this could be an R. Okay. So you may have more than one parameter for the templates. So it's like your functions are parameterized, right? You send your parameters to the function, okay? So, and these ones are parameterizing your parameterized functions. Second level of parameterization, that's why it makes it abstract. Okay, so let me erase these so that you don't get confused. Okay, so as I said, I mean, remember what I said about inheritance is just a little bit of syntax introduction, but a new, very large and useful word of inheritance comes in play. Again, just a simple header here, and now we have a new, very useful new word. Thank you. Very useful for word for us, and we are going to continue working on this. Again, there may be some complications, compiler-related stuff, technology-related stuff. We will talk about them in practice. Why we are doing, for example, this why we are using class here. I mean, it's a question. Well, they say that use type ID, type name, but we are using class. So these kind of conventions, how the seasoned C++ experts are using this kind of structures. So those are important too. So I will keep talking about templates today and tomorrow. I am not sure I can finish up tomorrow, but it will be there. Okay, so let's continue. Any questions? Yeah.
How compiler handles this type T, for example? I mean, it's like compiler produce same code for integer, double.
No, it doesn't produce the same code. Compiler produces okay, compiler takes this code, okay, since I called it with two integers, right? It makes a search and replace inside this code that replaces all the t's with an integer, and it compiles it. So it makes one runnable, callable swap values function, right? When you call this template with a character reference, compiler does the same thing again. Copies and pastes this one and searches and replaces all the t's with a character. If you call this with day of year objects, it does the same thing again. So in fact, compiler is doing whatever we are supposed to do. Compiler is doing, remember we copy, paste, and replace all those t's with the characters? Compiler is doing the same thing. Compiler is not doing very much. Copy, paste, and replace all those types. Okay? So every time you make a template function call, if that template is not instantiated before, it is just instantiated during the compile time, not runtime, during the compile time.
But for compiler time, it's produce and save the same code.
Yeah, it will be exactly the, well, I mean, the structure of the code is the same, but the types are different. So it is different. So in a way that compiler is overloading this function for you many times. As many times as you make a call with a different parameter
so
set.
This function templates for useful for programmers.
Sure, yes. Yeah. I mean, you just write one simple abstract code like this, but you call this many times with different types. And remember, our code is this is my whole code. This is how many lines of code? 30 lines of code. Inside this 30 lines of code, I wrote just one swap values function, templated function, but I call it with two different types. I could have called it with vectors, two vector objects, two day of year objects, two cell objects, two string objects. All of them would have worked. Okay. Every time I call this function with a different type, okay, compiler overloads the swap values with those types. So at the end, when you look at the assembly code, you will see that you will have 5, 6, 7, 8 different functions being compiled. Let's try it, in fact. Okay, let me copy this. Yeah, this swap values, and put it in my favorite internet site, Compiler Explorer, if I can do that. Okay, so let's get rid of add new. What add new execution source? Okay, let me erase this, or let me keep the mean. Okay, so this is my swap values templated class. Okay, and let's make some integers, I and j. Let's make some doubles, k and l, and I call swap values I, j, and swap values k and l, right? Okay, so let me try to see what I am getting in my compile. So how am I gonna get the compiler output? Is that no? I think I need to add, yeah, add new. How do I get the assembly view? Do you guys remember? Add more. You guys never play with this tool? I keep forgetting how I get the assembly view. Okay. Kill everything. This one. Okay. Now compiler. Yeah, here it is. Okay, so as you see, this is my main function. After the main function, there is a function named swap values with 2 integer references, and there is another swap values function with 2 double references. And as you see, the integer references one and the double references one, well, they are very, very similar. No, it is not. This is move st. These are all moves. So these are moving the doubles, right? They are very different. And as you see, the stack pointer is pointing to 24 before the stack, top of the stack, 32 before the top of the stack. And these are the same thing, maybe RBP minus 4. Yeah, minus 8. See, this is minus 8, minus 32. This is minus 4, minus 32. So the code is different. The thing that you are producing for the swap values integer is different than the swap values double is different. In assembly it is different. And there are 2 of them. And in fact, tell me some other string S1 and S2. I need to, okay, std string, right? And I need the include stuff. Include okay, string. Okay, good. So let me copy and paste this. And now I will have 3 of them, I guess. Swap values integer, swap values double, and swap values for Well, string. This is how the strings are done actually. Well, I have been telling you some lies about the strings, and when you see what the strings really are, you'll be kind of surprised. But again, swap value string is a little bit different than the others. It's a different type. All I did as a user is to write this 4 lines of code. Okay? So it is up to the compiler to produce the overloaded versions of those swap values. Okay? And if I erase this line, okay, that the overload for the strings are gone. Okay? So the compiler only produces the necessary instantiation of the swap values template. Okay? So again, I didn't run any programs. This is not a runtime thing. Everything happens during the compile time. Your compiled code doesn't know that it is compiling a templated version of some function. It doesn't matter where the code comes. It just runs, right? Your compiled code doesn't know if it is templated or not. So templated things are template instantiations are done during the compilation time. Good. Sometimes this happens. Sometimes if you do this, so it's a bad thing. Don't do this. K and J. Compiler doesn't know. Okay, compiler doesn't know. I mean, it's an integer. It's an integer reference, and it's a double reference. But t is the same. This cannot be an integer, and this cannot be a double. So this will not work, right? This cannot be instantiated. It cannot be instantiated, right? It cannot be instantiated because I have only one fee. But if I do this, again, don't do this kind of stuff, but let me make this, and so it might compile, but I don't think that when you call this kj, or I mean, because when you swap double with an integer, you're going to lose some data, you know that, right? It compiled, okay? So what happened here is that at line 14, both t and r became an integer. At line 15, both t and r became a double. At line 16, both k became an integer. No, k became a double, j became an integer. And let's look at the overload actually. The third one is a double reference and integer reference. Okay. Good. Yes.
If I give K and L in 16, is it compile?
If I
give K and L, line 16.
K and
L.
Well, that's what I'm doing, right? K and L, right?
In 16.
16?
Yes. We say.
Well, sure. Well, yeah. Okay, that's a good question. What would happen if I do K and L? And you are saying that just repeat line 15, right?
Yes, but we give parameter a different class, template class.
K and well, I did that already. K and L both doubles. When I am compiling line 15, I have already instantiated the template for the doubles. At line 16, I don't have to instantiate anything because there is a function that takes 2 double references. So when you see, there will be just 2 swap values. One is for the integer references, the other one is for the double references, and nothing else.
But we said parameter of variable 1 and variable 2 is different type, T and R.
Well, yeah, they are different, but in this case, they are equal. Okay, they are different. I mean, let's say m and n, 2 different integers. They are different, but their values could be the same, right? Okay. So obviously, I mean, you can always go wrong with the template instantiation, etc. Let me do this. Let me show you this. Okay. So this compiles, no problem. I am not instantiating any swap values. How about this? How about this? Am I making any? Okay, how about k, guess the value of y? How come it is compiling? It is not supposed to compile this one. So this compiler is smart. Usually what you do is with the templates, okay, if you don't instantiate them, it just compiles. Because without the instantiation, you don't compile yourself. So this compiler is doing some smart stuff and it is compiling. Usually this doesn't compile. Sorry, it compiles and it doesn't say anything, because as I said before, without this line, you don't get anything in your code from lines from 3 to 10, okay? Because I am not instantiating the swap values at all. So the compiler doesn't touch anything on it. I am sure if I use a different compiler, okay, not the so smart GCC, but some very early versions of, let me try to choose a different compiler. MIPS compilers, like that one, compiles, and KH, again, compile failed. I couldn't find it. Remember I told you that, this one? Remember I told you that the compilers behave differently? Again, this one compiled too. Some of the compilers don't implement all the required template instantiation stuff, and most of them, no, I couldn't find that compiler. It doesn't compile this one. Okay. The problem is not that. Problem is this. Is that? No. T and T. No, there is something else. I am not calling it, right? No, I am not calling it. Yeah. The point I am trying to make here is that this piece of code doesn't mean much if you don't call it. Okay? If you don't call it. It is different from a different function. For example, if I write a function f here, void f, okay, this void f has some code. Even though I am not calling it, it is empty. It is not doing anything. It is just stupid code, okay? But the swap value, since I am not calling it, doesn't produce any code, okay? So that's why some compilers don't look at this code at all if you don't call it. If you call it, it becomes a code, okay? That's why I'm surprised that when I do that thing, K assignment F, some stupid line, it just says, did I? Okay, how about this? Yeah, okay, good. Okay. That's what the point I am trying to make was that, okay, everything happens during the compile time, and if you don't instantiate the swap values, no code is produced. And back to your question, that's what happens. But this doesn't matter. Doesn't matter you call this f or not. Once you put this f here, it's a function. It has to be compiled. It has to put into your .o file, because maybe you are linking it with somebody else. If you link this .o file with somebody else, maybe that file is going to call this one. Okay. Any questions so far? Yeah.
What if we call f inside swap values?
Well, you call f inside the swap values. Again, well, it doesn't work here because I need to put it in before there. Okay, so swap values will not be compiled again because nobody is calling swap values. Okay, so f is here and you won't see any swap values. because nobody is calling swap values. If nobody is calling swap values, doesn't matter. Somebody has to call the swap values.
If
Yeah.
I put swap values in function f,
Sure, yeah. In that case, because you compiled f, right? And f is calling swap values, so it has to be instantiated. You are saying that okay, nobody is calling f. Why are we compiling it? Why are we putting it in our assembled code? Because as I said, if you link this file with some other file, maybe that other file is calling this function f. Okay, let's go back to our slides again. Okay, so go to the back of the discussions. C++ templates allow very general definitions for functions and classes. By the way, I showed you only a function template. I'm going to show you some class templates. For example, our class vector is a class template. Okay, we did not use any function templates up to now. Okay, and the type names are parameters instead of actual types. Okay, so it's like saying this. When you call the function of this, okay, try to understand this sentence. This is important. Okay, when you make a function call, you provide the parameters, right? This function needs 2 integer references, right? With the templates, you provide parameters to the function, also the parameters to the function as the types. You say that you will have these 2 integers, but you will have this integer as a parameter too. You are providing a third parameter. That third parameter is this one. You are saying that okay, I'm going to send you 2 references, and their types are integers. Okay, so you are sending the type of that t as a parameter to this function. You may think of it like that. Okay, you may think of it like that, or think about this vector class. When you say vector integer, it's like a class but with a parameter, so they call it parameterized classes. A class with a parameter, so you can change the behavior of the class by changing this parameter. Okay, so these are the parameterized classes, and the functions, they already have their parameters, but functions parameter types are fixed. Now we can change the function parameter types too. Okay, that's what we are saying. And the precise definition determined at runtime, definitely wrong. This is compile time. I got this from the book. The book doesn't say it that way. The book is correct. These slides are bad. Somebody else wrote these slides, probably a TA or something like that, and they are making lots of mistakes. I don't fix those mistakes, because those are common mistakes actually. Templates are definitely a compile time thing. During the runtime, as I showed you before, your produced code doesn't know that it was a result of a template instantiation. Okay, precise definition determined at compile time all the time, no exceptions. Okay, we talked about this. Okay, and I can overload it with the characters, and I can overload with the doubles and etc. And this is the syntax. So this is our template header. After the template header, you will say, these are my function code for this template. Okay, so it's called template prefix or template header. Okay, class means type or classification. Okay, type name usually is the documented thing. Put type name in there, but usually people don't do that. Most use class anyway. So unfortunately, we will keep using class anyway. I never heard somebody said kozyatağı. Everybody says kozyatağı, including the announcer in the metro, right? So we pronounce it that way, something like that. Don't look at me like that. It's not my problem. I mean, I didn't invent it. They are using it that way. Okay, so a template prefix, again, we talked about this, I guess. Predefined, user-defined, okay. T can be replaced by any type. Predefined doesn't matter if I am calling the swap values with the day of year object. It as long as let me go to this my favorite site again. As long as the assignment operator is swap values is defined on that thing, it's going to work. INJ, right? INJ is work. Does it work? Yeah. INJ. Did it produce anything? What is my? Oh, V is. Okay. So it worked. Let me do something. Let me do something that doesn't make much sense. Let me do. Okay. Variable. Tell me something that is valid for the integers, but not for the strings. What can I? Oh, okay. I can shift the integer by 1, right? By 1. It compiled, no problem, right? Question: is this going to work? I am going to put K and L. Is this going to work when I put L here? What did it say? I have a compiler error, K and L. Where do you think that I got the error message? I can open the compiler results and show you the compilation error, but I am not going to do that now. But it did not compile. The problem is with this line. It compiles, doesn't compile. Where do you think that I am getting the compiler error? All I am doing here is that what is right shift 1, right? When you right shift an integer to the right, you are multiplying it by 2 because you are shifting all the bits one by one, okay? But we don't do left shift, right shift stuff with the doubles because doubles are not that kind of data structure. So, compiler says that I cannot instantiate line 23 because when I try to instantiate line 23, line 13 is giving me some trouble. I cannot make it work. Okay? So this swap values function, I guess, could be instantiated by integer and that kind of types only, right? Not doubles, not strings, okay? Not doubles, not strings, not day of year objects. Only the objects that defines this right shift operator, okay? Interesting thing here. Let me show you something. Let me show you something funny. Can I do that? Can I? No. Because they are constants. No, I don't want to do that funny stuff now. Maybe later. Okay. So the point is, okay, where do you think that error line is reported if I open the compiler outputs? Do you think that I will get the compiler at line 23? Usually no. You would get the compiler error at line 13. At line 13 you will say that you are trying to use this operator right shift on a double. That's what you're going to be, that's your error is. Sometimes you get surprised because you will say that I have been using the swap values for many cases. Now all of a sudden it is giving me this error message because you started using it with a double now. Okay? So template instantiation has to be done with care. All the operations that you use inside this template code has to be valid with this new type that you are providing. In this case, it's going to be either integers or let me make this a short. Okay, with the short integers it's okay because short integer is an integer. How about characters? Does the character work? Yeah, it works. I never use a left shift, right shift on a character, but obviously it works. And it works with the long integers. And I was trying to do this declaration, declaration. What was the name of this thing? Declaration type?
There is no R. No. Delete R.
There is no, like, okay. Declaration type of CN. Oh, I need to include the CN and stuff. I was trying to do CN and C out. I was trying to swap the values of CN and C out because this one is defined for them, stream extraction insertion. But I realized that no, this is not defined for the C out. Those are two different objects. I was trying to make a compilable code that would produce nothing meaningful, but it's not going to work now. Okay, so I don't think that I can make this work other than the integer kind of stuff. But it might work for the day of year objects if I overload this operator for the day of year objects, right? If I overload this day of year object, it will work. It will work. Okay, good. Any questions? Any questions? No? Okay, let's take some break. 50 minutes. Let's be here around 10:32. Everybody sign this sheet. Burak, are you here? Burak Boyar, Muhammed Furkan Yıldız. Your slots are empty. Okay. You did not sign it?
Yes.
Thank you.
Listede boş yer var mıydı?
İşte sabah bir tane vardı benim en son baktığımda. Ben oraya hatta CSE normalde ikinci ders alıyor ya o register sheet'in çıktısını. Orası boştu öyle bilmiyorum. Yoksa
Kimse sevmez zaten.
aynen bence.
Ben 3 gün yazmıştım. Sizler neyse de.
Muhtemelen kardeşim ne yapacaksın ortaya mı?
Abi ne yapıyorsun? Onların söylediğini böyle. bilgisayarın yeri boş.
Sabah
Dışarı çıkar mısın?
Ama sen nerede ismini görmedim. İsim neydi?
Gözüküyor da diyorum size. Tamam. Evet.
Tabii ki. Nasıl bir deli evet.
Hocam, register sheet'e ben adımı manuel eklemiştim. Az önce Gebze'de eklemiştim. Benden önce davranmıştım. Tamam. Tamam mı? Ben elle ekledim.
Tamam, ona İlhan bakarken şey yapıyor zaten.
Okay.
Oradan karşılaştır, eğer yolda yoksa. Okay. So, without the template prefix, of course, it's not possible to write a templated function, so you need to put it. Okay, so any type could be replaced with T, as long as your code inside the function template is compatible with it. Remember, I couldn't instantiate that swap values function with a double because it included the shift stuff. Okay, so we talked about this actually. Okay, you write one definition in an abstract way, your definition of the class, your definition of the algorithm without depending on the types, and it works for all the appropriate types, not all the types, but for all the types that might be needed. Okay, when you call a function template like this, again, automatically your swap values function will be overloaded with 2 integers. Okay, so compiler generates this one, and it is done during the compilation time. Okay, here is another interesting and not useful template definition and call. Okay, its name is show stuff. Okay, it is templated, but it has 3 parameters. The first parameter I know it is an integer. Second and third I don't. It is a templated stuff. Okay, and this is implemented this way. Stuff 1 is definitely integer. The second and third one are of type T. And then this is my implementation of the whole function. I know that this one is the overloaded stream insertion operator for the integers, definitely. And this is for the end of line. I don't know what operator stream insertion overloads are these, because they depend on this T. Okay, if T is a double, then these are the double overloads. If T is a day of year, these are the day of year overloads. If stream insertion is available for the day of year. Okay, so it is possible to have these kind of template implementations. You know some of the types, the others you don't, etc. Okay, and in fact it is possible to write this kind of code too. Instead of, let's say, class T, you could say, no, well, maybe I'm going to delay that. I'm going to delay this discussion for a little bit later. Okay, there are many ways you can call a templated function, and I was going to talk about one of them, but I will delay it later. Okay, so this will work. Okay, your now show stuff will be instantiated by doubles, not by integers. Okay, so let's talk about this compiler complications. The thing is this. Template headers, okay, like this one, is no different than any function headers. So if you are going to use a template function in a file, you need to include the header in your code using an include statement, right? And usually we keep our implementation in a separate file, in an implementation file. That's what's supposed to be for the case of templates too. So you put this into an header file. This is the header for my templated swap values function, and you keep the implementation in a separate CPP file. And as usual, you compile and you make your libraries.o files, and later you link. That's what we are trying to do. But most compilers, unfortunately, did not implement all the requirements of the templates. Okay, so we cannot do this for most of the compilers. We cannot do this separation of interface from the implementation with the templates, unfortunately. So we have to keep all of our template headers and the template implementations in our header files. That's going to sound a little bit weird, and that's going to maybe disappoint you a little bit, but that's the way it is. We keep our template implementations in our header files. And if you wondered about vector header, and if you look it up, and if you load it and see what's going on inside the vector header, you will see that the whole vector class is implemented inside the header file. Okay, because it is templated. So the safe thing, I mean, the correct thing is separate the implementation from the header, but that doesn't work for many compilers. So what we do is safest in terms of compatibility with all the compilers. Safest thing is to place template function definition in file where it is invoked, and this is usually done by including the whole file in your in your implementation. And let me try to see here in this case. Okay, this is the first example, we did that. Okay, so this is my kind of the header file for the swap values, index of smallest, and etc. See this one? Sort.cpp. Sort.cpp is here. Okay, this is my sort header. I put everything. Okay, this is our example here. Swap values. It takes two references. This is my sort function that sorts an array. Okay, this is another. The third one is another template. We are going to look at it in a few minutes. And this is our sort.cpp. It implements the sort function, the swap values, and the index of smallest, etc. But when it comes to using these, this is what I do. Okay, I include this sort.cpp, and I am doing something wrong here. No, that this one. No, I think I played with this code last year and I kept it like that. No, okay. I am going to get rid of this one because I already did those. Okay, and this is going to be okay. I will include sort.h, I will include sort.cpp, and I will call this sort function. Sort is okay, this is the header. This is the source code, okay, and inside my main, inside the file that calls the main function, I include all that code, okay. In this case, unfortunately, I have to send, what am I gonna do? I have to send my implementation file to the customer. Otherwise, customers cannot use it. Otherwise, customers cannot use my nice sort function, templated sort function. Like they send us the source code of the vector class. Okay, when you include the vector, okay, source code for vector .h, it's going to come from somewhere. Okay, gonna project good. Okay, vector source file. Am I getting it? Yeah, I hope so. Okay, so there is a class definition. This is a templated class, and as you see, I am calling stuff. I have implemented this begin iterator. I have implemented our begin, all kinds of stuff. So how many lines? I don't know. It is 600 lines. This is 600 lines only for this one. But if I have this one, let me see this one. This one might be even more profile. Okay, good. Am I getting it? So it is 600 lines is a little bit less. So I was expecting it would have been more than a few thousand lines of code, but it had some other includes in that too. Let me see if they are there. Kind of slow. Where did it go? Was it? Maybe I should go back and one more. Vector source file. Yeah, see, it includes some iterators, and it looks like it is this, but I guess it is namespace template class vector. Yeah, okay, so it is using some stuff from the base classes. So it is using multiple base classes, multiple inheritance, right? And it is templated, and in fact it has two template parameters and we are not using the second one. Why? Because this is defaulted. See, this one is defaulted. Okay, so the other than the base class code, okay, we have everything in this file, and we have to do this so that we can stay compatible with all kinds of compilers. So we have to make one big compromise here by not hiding our code. But this is what we tell our customers. We say that I am going to give you the source code for the sort.cpp. Okay, you are not supposed to look at the sort.cpp because that's my hidden information. The fact that you can check it out doesn't mean that you are going to make a modification on it, or doesn't mean that you are going to write code that depends on the implementation of sort.cpp, because anytime I can send you another sort.cpp with a different implementation. Okay, I own that file. Okay, and if your client code breaks because I am changing something in sort.cpp, it's your fault. It's not my fault. Okay, so and that's what we have been doing actually. We never looked at the vector.h or string.h, right? We have been using them. And all of that. In fact, you may wonder why I am talking about string here. String is a vector, is templated class too. Okay, string is a templated class. We didn't look at its definition yet, but nobody wondered how the string is working, and nobody wondered what kind of things it has in it. But we have been including this whole source code of the string class when we include string.h in our system, and we never went there and see how the thing is implemented. So it's a compromise. It's a bad thing that we are including a source file, but again, if you keep all the rules in mind, sometimes we have to do this kind of stuff in the real world. Important thing is that you should know what is the perfect behavior, what is the perfect coding style, and you should also know that if you follow the perfect coding style and all the rules, sometimes life is not bearable. Okay, you cannot go on, so you have to make some compromises. As long as you know what you are doing, as long as you know what kind of values you are breaking, what kind of rules you are breaking, you should be kind of okay. Okay, let's go back here, compiler complications. Okay, typically we have them separate, but unfortunately it doesn't work that way. So it is safe to place them in the file where invoked. So it means that if you are making the template instantiation in a main function, keep your template definition in your file that includes the main function, but that's not common. So that's what we do. We include the file that contains the template code, usually in a header file. Usually we put everything in a header file and we include it. Okay, so check your compiler. Compilers behave differently, and most of them actually implemented this separation of template header and the implementation. But sometimes they have to work with the old compilers, some old systems. So this behavior kind of stuck, so we are using it. Okay, good. Another topic. Any questions so far? Yes.
Should we put it's not defined in CPP file?
Usually we put them in a header file. Yeah.
But if we not put, then it can include second time or more.
That's why you have your guards, right? You have your guards, multiple inclusion guards. That will work. Usually we put everything in a header file, like the vector. I showed you this one, right? So the definition of vector is here, and I have this if not that defined stuff. So this prevents it from being included more than once. Okay? There is no difference up to this one. Okay, you see there is another vector here, include vector. I don't know what that is. I wonder if that one is, yeah, So there is another. So it must be about these base classes. Yeah, there is vector. See this one? Vector. Anyway. Multiple type parameters. You can have a template definition with more than one type. T1, T2, TR, KL, whatever. The book says it is not typical. I don't agree with it, and I showed you one example there, right? Vector, the class vector has it. So multiple type parameters are possible, and they are used frequently actually, especially with the classes. And these are some of the rules. So you cannot have any. You don't say that I define class T1 and class T2, and you didn't use the T2. It is not done that way, but you have to use both of them, or all of them. Okay, so this is the whole thing, the whole idea about the templates. It's the algorithm abstraction. As I said before, I mean, we don't say that templates are one of the main pillars of the object-oriented programming. It is outside of the object-oriented programming, and in fact, you can use the templates in other languages without any reference to the object-oriented programming. And in fact, actually, a template is something like a smart macro, right? Remember macros? When you say, remember this one? Define square x, and I will define it like x times x. So whenever somebody says square 1 or square 1.2 or square some large value, this code is replaced with this square, right? This is a macro. This is kind of a template. It works for all kinds of types as long as this multiplication is defined. So I wrote a very generic square function, and it works every place. So it's a very primitive template, but it's a template. If I make this a little bit more complicated, okay, maybe I can say this. Let me try to write a template for you. Okay, I am writing this. I'm not going to, okay. So the square of x could return a declaration type of x. Its name is going to be square, and again declaration type of x, a parameter p, and you see what I'm doing? I am writing a function in a macro, and I will return times x, and let me not forget about the backslash character, so that, okay? So every time I say square integer or square, why don't I, no, why I didn't have to write this thing, okay? I just say, okay, I will say, I will take an x, I will return p times p. This is much better. And I don't have to do this. Just return p times p. Okay. So somebody calls this square with square integer, and my system, my processor will produce a code for the function that returns the square of an integer. If I say square double, it will be for double. If I say square character, it will be for character, right? So my macro is writing a function for me, and it's kind of a template. So all I'm saying is that you can apply this idea to the other languages that doesn't have any support for the object-oriented principles. And the idea is simple. You just provide me the algorithm itself in an abstract way, and I can handle this replacement of those generic parameters with the real parameters. Okay, so and we see in C++ or in Java or in C Sharp and in all those programming languages, this idea is there, and we can use them free of any object-oriented programming principles. Okay, we have the function templates, we have the class templates, and both of them are available. Yes.
So you are not sharing screen.
I am not.
Sharing screen.
I am not sharing my screen.
Yes.
And in fact, I am not in the meeting. What? And nobody is telling me anything about that because they are not seeing. And nobody is telling me anything. Okay, here is Mustafa. Mustafa. Yeah, and this. Mustafa, I am going to kick you out as soon as I see you. Okay. I can't kick you out. I am the owner of this meeting. Okay, next time I will tell you, I will kick you out. And I'm going to erase your name from the attendance list. How come nobody told me that? So you have been watching me in your on your cell phone,
Yeah.
and this happened just now, or
Yeah, 4 minutes ago.
4 or 5? Okay, so it is not since the beginning of the. Okay, thank you. So I am recording it and I'm sending my voice and everything. Okay, good. Okay. So how do we write templates? This is what I do. I write a regular function like a swap values. Okay. I write a swap values function for integers. I test it. It works. And then I replace all the integers with a t, and I put template class t header at the beginning. So I first verify that it works for a concrete type, for integer or double. After I make sure that it works, then I make it a template. Because writing a generic code without testing it is very difficult. Okay? So first write it without thinking about the templates. Once you make sure that it works, then you make it a template. And you instantiate it and you test it. Okay? This is what I do. This is what the book suggests. Okay, develop function normally, completely debug ordinary function, then convert to a template and instantiate it and test it again. Okay, because for some reason we can work on the concrete stuff better than. Is that your face? That's so interesting. So I know your face now. That's you have seen all. You all have seen my face, right? You can see I never seen your faces. This guy sits always in front of me. This is the first time I have seen his face. For some reason, we work on concrete stuff much better than the abstract stuff. As humans, we like concrete examples. We like to work on concrete stuff. We like to touch on stuff like this and play with them because these are concrete. But for some other reason, abstraction is something we like too. We are not very good at it, but we like to talk about the abstract stuff because it is easy to talk. And in the abstract world, all you do is just talk actually, and some of that talk can turn into concrete stuff. Okay, so work on the concrete stuff first, make it work, and later make it abstract so that it is more useful to everybody else. Okay, good. Okay, so we talked about this actually. Inappropriate types in a template. The fact that you have written nice swap values function doesn't mean that you can call that swap values template with any kind of types. For example, this would be, look at this one, swap values A and B. It will not work where? It will not work in the place where, because A is a constant integer pointer, B is a constant integer pointer too. If I take the references of it, it will be constant references of constant reference of integer pointers. And inside my swap values template, there is an assignment statement. An assignment statement will not work there, right? So this will produce a compiler error, like I did with the doubles with the insertion, left shift, right shift, etc. So templates are meant to be generic, are meant to be good for all kinds of types, but unfortunately this is not going to be possible for all kinds of types, because even the assignment, the simple operator of assignment, is not valid for some of the types, such as the constant pointers or the constants, right? So it has to be an appropriate type for that template. Okay, think about our sort function that we are going to look at in a few minutes. That sort function can work only for the types that know how to compare themselves with the others. Less than operator, greater than operator has to be defined for them. Okay, if it is not defined, then I cannot sort them. The vector class doesn't know how to compare them with the other vector objects. It doesn't know about the less than, greater than operators, right? So again, let's look at this example from the book. The book talks about this sorting example. I included sort.h, I included sort.cpp, okay? And in fact, this is what I would do. I would take this from here and put it inside sort.h and somewhere here, okay? So, and don't forget the guards. I didn't put the guards here yet. And only include sort.h, because sort.h includes sort.cpp, and this should be fine now. So this one, let's look at the main function first, like the regular object-oriented behavior. Let's become a customer. Let's see how it works. I make an integer array like this of size 10. I print them out on the screen. Okay. Then I call this sort function with a and 10 and print them on the screen, and you will see that everything is sorted. Then I do the same thing with the doubles, and it works. And I do the same thing with the characters, and it works. And I can do the same thing with string, and you will see that it's going to work. So I have written a sort function just once, and it will work for all kinds of types that knows how to compare them, how to compare their members, less than, greater than, equal to stuff. So this is probably will work strings again. I don't think that it's going to work for the day of your class, because we didn't implement the less than, greater than operator for the day of your class. Okay, so main is this part. Let's look at the source code. Sort.cpp. Sort.cpp does this. Okay, we are going to use what kind of sort? We are index sort. That's what we are going to do. Okay, we are going to pick the smallest element inside the list, inside the array, and place it at the beginning of the array. Then, okay, then we are going to choose the smallest in the rest of the array and place it at the beginning of the next array, and etc. So index of smallest is a templated function that does that. Okay, let's look at this index of smallest. Templated class T, it takes a array of T, start index, okay, and the number used, how many elements I'm going to look at it, okay. So at the beginning I say my minimum is a start index, okay. My minimum is at the beginning of the array, and my index is my start index, and I have an integer index starting from start index plus 1, and it is incremented until it hits the size of the array. And then every time I make the check, if A index is less than minimum, then A index becomes minimum, index becomes index of minimum, and I continue this loop. By the way, this is a mixed style template. It has a array of type T, starting index and end of the array here. Okay. So this is that kind of a. So these are integers. These are not T. This is not T. This is not an T. This one. Okay. This integer and index of smallest of an integer array. The meaning of this integer, and if I use this with an integer, the meaning of this T integer are two different things. Okay. This one is integer because of the algorithm itself. If I call this index of smallest with an integer array, that integer is part of the input. Okay. So two different meanings to the integer type. Okay. Any questions on this? Okay, it's nice. This is a constant, and it is returning in the index of it, returning the index of minimum. Remember what I said? I said that if I am writing this from the beginning, from the scratch, I would have implemented this for an integer, then later converted to a templated. And when I converted from integer to templated, I will replace those integers with a T, but don't replace this integer with a T. Don't replace this integer with a T or this one. These are meant to be integers. This is a T min. The type of minimum is T, and the type of index min is int, definitely. Okay? So there are some tricks in changing from a concrete function to a templated function. Okay? So this is the index of smallest. It will return, it's like this. It's like this if I have an array. Okay. I have numbers 21, 7, 2, 13, 5, 71, 3, and 5. First I call this index of smallest on this whole array. It will say that your smallest is 2. Okay. Then I will swap this one with this one. Now I have this array. 2 is here, 21 is here, and the rest of them is there. Now I'm going to do the same thing with this array. Put the smallest at the beginning, okay? And do this with all the elements of it, and at the end you will end up with a sorted array, okay? So that's the sort function. Okay, let's look at the sort function. Say that I am going to sort, by the way, this one takes a non-constant T array, but while this one is calling the index of smallest, it says that I promise I am not going to change anything inside this array A. So this is what it says constantly. So that's a good behavior. Okay. So I am going to do this from 0 to a number, use -1. I'm not going to do it for the last element because last element is going to be the largest anyway when I reach it. Increment the index. Find the smallest one from index to number used every time, and swap those two values, the index one and the index of smallest. Okay, and swap is already there, it is implemented. Okay, so when you call this sort with an integer array, okay, the compiler sees that there is a sort function templated. I can instantiate it. While it is instantiating it, it needs to call this index of smallest, and it sees that it is templated, so instantiates it, and then it instantiates the swap value for the integers. At the end of compiling the sort code, I ended up instantiating 3 functions: sort, swap values, and index of smallest. They are all written generically nicely. And as long as, so what kind of operators, what kind of things we need to have in order for this sort to work? Okay, definitely T has to be, assignment operator has to be there because I am using it here, right? For the one. So for the T values, assignment has to be there. What else? What else? I need to compare the values of T. That's less than operator has to be defined. No greater than operator or equal to operator, but less than operator has to be defined. Assignment and less than. And I don't think that I have anything other than those, right? Then I should be fine. Yeah, just two simple things. Assignment and less than operator. That should be enough for me to call this function on my T types. Okay? Any questions so far? Okay. So these are the function templates. Sometimes let's say you have a templated function, for example, f. If I call this f with a 1 integer, it is already instantiated. Sometimes I can force it. I can say call f with a integer instantiation. Okay, I can force the compiler to instantiate it with an integer. Okay, and sometimes I do this. If I don't use this integer here, it's going to try to instantiate it with a double, but I'm saying that instantiate it with an integer if it is not instantiated yet, and then call that function with 2.0 with a double. Nice, not nice code, but possible. Okay, so you are saying that I am calling this instantiation. Good. Any questions? Okay, if there are no questions, then I will start talking about class templates, like the vector class or the string class. Let's look at the string class. Let me go to the definition of the string class. Can I find the string class? I didn't write Control F. Okay. String. Basic string H, yeah. So string is actually an instantiation of basic string. Okay, this is the basic string class. It is loading, it is loading, it is loading. Yeah. Okay, so basic string class it represents a string of types. Our string class is a string of characters, but you can have string of integers or string of doubles or string of day of year objects. You understand? So we have been using, when I say string, okay, there is the definition of type def string, type def string. Can I find it somewhere? Okay, so let me do this. C++ type def string. Can I find it? Somewhere in the string header, it says that the type that we are using for string actually a string. Yeah. Okay. This is our string. Our string is actually a basic string vector, the templated class basic string instantiated with a character. That's what we are doing with the string class. So it's a type def. Later they added other strings, standard strings, U8 string, U16 string, U32 string. So, I mean, our string obviously can handle characters of English language, but characters of Turkish language is kind of different. So for that one, we have these wide strings, okay? It's called W string. You can put Turkish characters inside wide strings, okay? And other types of strings are available. And if it is not available, you can have a string of. What is the difference between string of integers and vector of integers? What is the difference between a string and a vector of characters?
One is dynamic, other one is not.
Well, both of them are. Why not? The string, I mean, when I say string, it is string of C++, right? Or I mean, I'm talking about. So, what is the difference between? Okay, more. Okay, std string and std vector character. So what is the difference between these two? Yeah. What? What does he say? I don't understand what you're saying. Why don't you say it louder?
Null character.
Null character?
Yes.
Oh, you mean that this one has a null character at the end, this one doesn't? How do you know? Nobody told you that how the string works. I never told you. No. Maybe you're talking about the C types of strings. This is not C type of string. I am not talking about character str50. Well, that's the difference, maybe this one with this one. But I'm talking about C++ std string. Yeah. Yes?
One thing that comes to my mind is that with vector of characters, you cannot assign the same way that you would do with the string.
Well, the assignment works, but with the strings you can do this kind of stuff. Right? String assignment S2, right? Concatenation. It is not available for the vectors.
Yeah.
And also, I can't say this with the vectors, right? Less than, greater than, etc. Okay? So this one is very different than this one, and this one is actually a basic string of characters. And you can have a basic string of integers too. And you can have a basic string of doubles and day of year objects and etc. Okay? So string class is actually an instantiation of basic string with a character. Okay? Basic string with a character as defined in this header. And it looks like they kept adding more stuff. C++ 11 has this, and 11 has C++ 20 has this, and W string is available for C++ 98. Okay, so how are you gonna keep all these in your mind? I mean, so you don't actually. You just look at the documentation and etc. And by the way, I think string comes from string traits. Properties of a character, okay? So you need to read them what they are for actually. So, and these kind of things are available for all of them, less than, greater than. These are not available for the vectors. These are only available for the strings, and stream insertion and extraction is available. For the vectors, it is not available, right? And conversions are available after C++ 11. And begin and well, these are available for the vectors too. Okay, so we are going to see what it means to write classes like vectors or the basic string classes, templated classes. Okay, that's what we're going to do, and it's not complicated. Let me show you your first templated class. That's it. a pair class that keeps two data members. Their types are T, okay? Very simple class. All it does is I can set the first data member, second data member, get the first and get the second. That's it. And of course, I have my what constructor. Okay. So now I can have, if I put them in my header, I can have pair of day of year objects. O1, O2. It works. Okay. I can say O1 dot, O1 dot. For example, I can do this for the beginning of my employment and ending of my employment thing, right? Okay, two stuff. Or beginning of the semester, end of the semester. I can represent those. So O1 dot get first will give me the beginning of the semester, and the get second will give me the end of the semester. Okay? If I like to go crazy, I do that all the time. I can do this. Tell me something. Tell me something crazy. What? Pointers are not crazy. Just erase that in your mind, okay? Pointers are nice. Don't call that pointers crazy. Crazy thing is this: pair of day of year, day of year objects. Okay. I don't know why this is useful, but it is available and you can use. Don't forget to put the space in between here, right? It's a very nasty error. It's a space there. Otherwise, compiler thinks that it's a right shift operator. Okay, so a pair of here. So all I did was just write this code, and I can implement everything is like with the inline code. Get and set stuff here, and it is as simple as this, and somehow it starts working for everything. So what do you? Okay, to be able to use this pair class. Okay, to be able to use this pair templated class, what kind of objects, what kind of t values can I send? It would work for the integers, it would work for the day of years. So what are the conditions? The set first assigns a new value to the first, this one the second, and what else? Okay, can you tell me what kind of requirements should I impose on my instantiation classes? It works with the integers, day of years. So what is the minimum for my class to work with the pair class? It should have maybe the assignment operator, right? Because the assignment is going to work here. Okay, I told you that. Other than assignment, do I need to have anything? Very simple class. There is one very important requirement actually. Other than assignment, what should I have?
Copy constructor.
Copy constructor, exactly. Yeah. Copy constructor. Why? Because I am passing these t values by call by value. For the call by value, there has to be a copy constructor. You might say that there is always a copy constructor by default, but maybe you choose it to make it private. In that case, this will not work. Okay, good. Any questions? When I say good, it is not good. Actually, you are not asking questions. It is good for me. I mean, I am saying I'm good.
What about destructors?
What about?
Destructors.
Destructors, no, doesn't have to. I mean, in this case, I mean, if you make your destructor, private, okay, you cannot make any objects of that class anyway. I mean, constructor is the same thing too, right? If there is no constructor for your class, you cannot make any t objects, and it will not work. So what you are saying is true, but I mean.
I mean, if we send pointer and we allocate memory,
Yeah.
then that memory will be leak if we don't add destructors.
If you don't have a destructor, yes, I mean this will not work. Yeah, that's true. That's true. Yeah. So like the copy constructor, destructor has to be public. Okay.
But
What?
how we can sure, I mean, if not send pointer or reference, then we don't need
Destructors.
destructors.
Well, it is not easy to use those kind of classes actually. I mean, if you made your destructor private, if you made your copy constructor private, okay, obviously you don't want to use your class with these kind of templates, so it will not be usable. Good. Okay. I have one more question. Good.
Are there any reasons that we didn't write T first, comma second instead of T first, semicolon, T second?
Instead of what again?
T first, comma second.
Oh yeah. Well, it doesn't work that way. This is how C++ is defined. I mean, this is not declaration of local variables. This part is for the declaration of your data members. And your data members has to be declared one by one with their own types. You try it, it doesn't work. Okay? Okay, I will see you tomorrow then. Thank you.
Hocam merhaba.
Merhaba.
Yoklamaya adımı yazdığımı sanıyorum da galiba yazmamışım hocam. Sağ olun.
40'ı doldurmuşuz ama sen kaçak mı dinledin dersi?
Galiba.
Ha, tamam, iyi, helal olsun.
Doldurduğumu sanıyorum hocam da kaydetmemiş galiba kimse.
Kaydetmemiş diye bir şey yok, o güzel çalışıyor. Ama yoklama dolu yani, 41'den dolu şu anda.
Yani ekleme şansınız var mı?
Yok,
Tamam, sağ olun.
kaydedip yarın gel.
Hocam bir şey sorabilir miyim?
Zor değilse sor.